Hello guys, welcome to this channel. Today we'll be starting a new chapter on the studying and understanding of linear functions. We are starting with the topic Introduction to Linear Functions. Here we are going to learn about the understanding the basis, the graphs, and the real-life applications of a linear function. What are linear functions? Linear functions are algebraic expressions in the form of a function where the highest power of the variable is 1. So it is going to be in the form f of x equal to ax plus b. In this case, x becomes the variable. The a and the b becomes the constant. Example is y equal to 2x minus 1. What we need to understand here is such that a linear function forms a straight line graph when plotted on a Cartesian plane, as you can see on this particular graph. So this is a graph of y equal to 2x minus 1. So this particular expression is a function, and the function contains a variable, and the variable is raised to the power 1 as the highest index, so which makes this particular function a linear function. So when you look at the graph, it is a straight line segment. So the graph is a straight line segment. So that is the definition of a linear function: an algebraic expression with the highest powers of 1 in the form of a function. So anytime you see an expression of such nature, then it means that we can grade such function as a linear function where a and b are constant. We can also apply linear function in a way with contents such as speed, cost, and growth. Good. Now, why do we study linear functions? So why study linear functions? We study linear functions because it can be applicable in real-life scenarios like cost prediction, distance time graph, budgeting, and others. It also serves as a foundational for higher level math topics. So if we want to understand higher level math topics, there is a need for us to have the understanding of the studies under linear functions. It is widely applicable in science, engineering, economics, and data analysis. So linear functions are widely applicable, so it makes it more important for us to understand how linear functions behave, its nature, and whatever thing that concerns the studying of this particular function. Let's look at this particular image here. Why we study linear function. And we studied linear function in predicting trends in data. It helps a lot in budgeting and finance. We also use it in modeling linear relationships. Let's move to the next topic, the next subtopic here. We have the types of linear function forms. So, what are the types and what are the ways of presenting linear function? Look at number 1 here. A linear function is being presented in the form f of x equal to ax plus b. It can also be presented in the form y equal to mx plus c, and it can also be presented in the form y minus y1 equal to m bracket x minus x1, where look at the definition of the letters here, where a, b, c, m are the constants. So look at a, b, m, c in this particular expression. They are known as the constant. Then the x, y are the variables. M is the slope. C is y-intercept. So let's look at the number 3 here. We are having x1 and y1. The x1 is representing all the s coordinates on the line segment, and the y1 is also representing all the y coordinates on the line segment. So when we write x1 and y1, it means that we are talking about any point on the line segment. So let's also look at the m here. M represents the slope, which is used to measure the steepness of the line. Good. So then the y is also representing the intercept. So when you look at the example here, the graph of y equal to 2x minus 1, it takes the shape of y equal to mx plus c. So here we can write the letters based on their correspondence. So we can have m to be the same as 2, the x is still x here, and the c to be -1. And we are saying that c is representing the y-intercept. So when you look at this particular line segment, you will see the y-intercept at this section here. So at this point, x will be 0 and y will be -1. So it's true that whenever you present a linear function in the form y equal to ms plus c, the c here will be the part, or it will be the y coordinate of the point where the line intercepts the y-axis. Let's look at the characteristics of linear function. So a linear function can be identified by its nature and its characteristics. So number one, all linear functions have a constant rate of change, and the constant rate of change is what we call the slope of the graph or the function. Good. Linear function is also having a straight line graph. So anytime you see a straight line graph, then it means that we are also talking about a linear function here. Then that particular function is also a linear function. We can also know this particular characteristics of a linear function. It involves only two variables, and the only two variables here that we are talking about can be a variable in the form of only x and y, and the degree of the function too is 1. So all linear functions have degree 1, as uh, it has been presented to us during or in the first slide. Okay, so let's also connect linear function with an arithmetic sequence. That is one example of its application. So arithmetic sequence, the terms is being presented in the form un equal to a plus n minus 1d. So at this point, the d signifies or represents the constant rate of change, and it is known as the constant difference, that is the slope, also representing the m. Good. So look at this particular sequence that we have here. We have the sequence is 3, 5, 7, 9, 11, and 13. Good. So the constant rate of change between this sequence is 2, because 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2, and so on. So that is the reason why linear function or an arithmetic sequence is in the form of a linear function. Let's look at the graphing aspect of a linear function, intercept method. We have y equal to 2x minus 1. If we want to graph this particular function, first we need to find the intercept on the y-axis. So intercept on the y-axis means that we put x to be 0. So when you put x to be 0 here, you are going to get y to be -1. So that will give us the point on the y-axis. Then the next one, intercept on the x-axis. In this particular aspect too, we put y to be 0. So when we put y to be 0 and solve for x, we end up getting 0.5 as our answer for x. Therefore, the point on the x-axis will be 0.5 and 0. Then we plot and connect this point on in a straight line form, as you can see here. So when you see this particular graph, you can see the point here representing the intercept on the y-axis, the point here also representing the intercept on the x-axis. Then you use a rule to join this point in a straight line form. So as you see them, you can see this particular graph. It is a graph representing the linear function y equal to 2x minus 1, with this one as the point of intercept on the y-axis, and this point as also the point of intercept on the x-axis, using slope and y-intercept. So we know that y is equal to mx plus c, and this one, whenever a linear function is being identified in this form, we can easily identify the slope, which is m. So how do we find the slope when even the graph is given to you? The slope of a linear graph is being represented as the rise divided by the run. The rise represents the changes that occurs at the y-axis, and the run represent the changes that occurs on the x-axis. So look at this particular 2 points here. We have point 2, 3 and point 1, 1. Here the y coordinates are 3 and 1. So if I want to get the rise, then the rise will be the changes between these two numbers. So here, if I want to know the rise is 1, 2. It means that the number of times I've risen to this particular point, from this point to this point. So when you look at it, it's going to be 3 minus 1. That is the difference between the y-axis. And 3 minus 1 will give us 2 for the rise. And the difference between the x-axis, the x-axis are 2 and 1 respectively for each point. So if I want to find the run, which is this horizontal line here, it is only one step, and so the run is 1. How can I confirm that it is 1? Then 2 minus 1 will give me 1. So 2 divided by 1 will give us the same as 2. That's the reason why the slope is of this form. And you can also locate this point. That is the point that we have used to calculate for the slope on this particular graph. So let's go to plotting a suitable point. You can plot a suitable point on the graph. Here, just locate the x coordinate to be 2, y coordinate. Example is here. X coordinate being 2, y coordinate being 3. If I want to plot this point, I'll locate them from their axis, then plot the point at where they meet. So this one continues. Anytime you want to plot a point, you can use this idea to plot your point. Then let's look at the movement of positive and negative gradient on a graph. So we have the red line here and the green line here. All of them are linear graph, but one is starting from the left to the right. One is also starting from left to the right in an upward form, and another one is starting from the left to the right in a downward form. So the green line is rising and the red line is what, falling. So when the graph rises, it means the gradient is positive. So here the gradient is positive 0.5. When a graph falls, it means the gradient is negative 0.5. So it means the gradient is negative. So look at it. So one gradient is negative, one gradient is positive. So anytime you see a graph or a linear graph, you have to be able to identify whether the gradient to be positive or the gradient to be negative. Good. So look at this real life example here. We can attribute this one to a linear function that is about a taxi fare. When you plot it, we can realize that here x coordinate is 4 and y coordinate is 17, based on the linear function which has been modeled here. Good. So we can also do some class activities to understand the concept. So this is the summary of our work. So we can learn this thing in an easy form to understand the basis of an advanced algebra and calculus. God bless you. See you in the next slide. Thank you.